So you already touched on this aspect also, the fact that more and more we're seeing end users using mobile platforms.
Yeah.
And mobile platforms are tying into the cloud. And so as this future revolution happens, in the data center, things are changing. What do you expect as changes that are happening at the consumer end of these services?
To be honest, the consumer end is driving most of this. And the classical enterprise IT is following. So the consumer revolution in mobile and small devices and the like are driving much of what I described here. And the benefits then is accruing over time to more usage of the systems. So give you more examples.
Right.
With more and more collaboration needs or sharing of state, you're going to put more state in the back end to be able to share them between multiple users. With the need to do things beyond just messaging, sharing data, sharing state and the like, you'll find out that data will flow quite a bit from the devices to the back end. And their physics, however, the device cannot be very big. The battery of the device cannot be very big. So the device can only do so much. So the back end has to do it for you.
Right.
And finding the balance between them will change over time, of course.
But this also brings an interesting concern. That is, as you said, there's going to be more that's happening in the back end because the mobile devices may not be able to do it all. And you also mentioned that there may be collaboration among the mobile devices. And a lot of the things that happen in mobile devices today is streaming kinds of things. And how ready is the cloud for dealing with that kind of traffic? And in particular, you also mentioned that cloud as architected today is throughput oriented, not so much latency oriented. So what do you see as changes that might be coming down?
The different type of streaming out there. Okay, so for the bulk of internet traffic, by the way, are streaming of pre-recorded material. And the way the internet can handle it at large, as you know, it's mostly through caching. So you have so-called CDN networks, content distribution networks, where the content is stored at the edge closer to the user. And once you ask for a movie and your neighbor asks for it, the second time is almost free. And by and large, that's sort of working, frankly. I mean, depending where you are in the world, Netflix, for example, in the US is very big and so forth. To do more real-time, it becomes more interesting and more cumbersome, to be honest. And I think things will change as well. But I have to tell you, I am myself amazed how well it works already in that sense. The latency aspects have to do with, ultimately with physics. So there will be cases where if your application requires a lot of chatty, lots of protocol between a component and another component, you have to think seriously about where they should land. If it's very chatty and physics as the same, we cannot change the laws of physics. They have to be closer to each other. So decomposing the app, whether it be real-time live streaming of data or video, whatever, is very important to put chatty stuff in where they should land versus where they can withstand a long distance.
Right, but that also brings up the question of data centers as they are architected today. They are, as you mentioned, they are in some dark room somewhere. But if my mobile device is latency sensitive, shouldn't they be closer to where the mobile device is?
There will be multiple levels. Okay. So you want to put some computation on a device. That's, if the latency between two components is so critical, there's no way you can cross any wire. So some will live in a device itself. Some will live on the edge of the network before you get to the actual DC. And increasingly, the mega services on the internet don't directly hit, you don't hit the DC directly. You go to an edge somewhere. And you do also WAN optimizations, TCP IP optimizations. For example, you may land to an edge closer to you, and there, the connection between that place and the actual DC are aggregated over common TCP IP connections. So tricks like that are important. Latency hiding tricks are important.
So this next question I'm going to ask you is more related to from a student's perspective. The students that are taking this course, this is an advanced operating systems course, and these students, they may be aspiring to work in leading software companies such as yours. What would be your advice to students that are taking this course? Specifically, can you talk to the students about the opportunities that exist for OS designers today in the industry space? and how the students should prepare themselves for such opportunities.
Sure. I'll be honest with you. You may not design a new OS from scratch. We have a bunch of them already. But every concept you're learning here will be needed, more than beneficial, needed when you move up and down the stack. If you're doing an application, like much of the discussion we had right now, a high-scale application, it's no longer writing an application to run on a machine by itself, displaying to a screen. All the issues we touched on, you have to worry about. You have to know about them. You have to know about caching at scale. You have to know about synchronization, data replication, handling failures. So all these concepts you have in a classical OS sense are directly applicable regardless where you live up and down the software stack. So I'm convinced that without a strong foundation in operating systems and a few other topics, programming languages and the like, one cannot handle or build those big applications. You could do some simple web programming, do some JavaScript and a nice animated screen. Don't get me wrong, this stuff is important. But if you want to do the real scalable services where the industry is moving, you have to have the foundations. More generically, you have to also use the information you learn here and be ready to learn more and to apply it in different domains. So the classical papers that you taught me way back then are still relevant. But as we discussed, you may have to apply them differently. You have to morph them, evolve them into newer areas.
So I want to make sure that the students get an idea about specific things that you think that they should get when they are in school. What are the things, if you can specifically, can you name a few things that you think are important for students to get while they are still a student here?
College time, the time you're taking right now to learn all this stuff, is the most exciting time, to be honest, because you can keep an open mind and go wide. So learn as wide things as possible. If you want specific things in computer science, let's be specific here. Definitely operating systems, distributed systems, and definitely programming languages background. I think they're very important. They're foundations for any platform level type of work, if you will. Know the classical information, but also know how to apply them in what you actually have in every day and the like. What else would I want to do? Frankly, beyond CS, I would also try to get other background that complement what I do. Even things like humanities and the like, they're actually important. Because when you move up and you want to work in industry and the like, much what we do, we actually write code. We design code, we implement and so forth. But we also no longer build things by ourselves. None of the systems you have and in your disposal were built by one person. They're built by teams. So learn how to work in teams. Learn how to deal with other people like you who have to collaborate and build software in the large. Some of these tricks you may only learn the basics in college, but as you go forward, you're going to apply them to build large software. And also, don't shy away from the tough assignments. Push the envelope where you can right now. They'll come back and you can really apply them as you go forward. Lastly, a good foundation in just knowing the basics of computer science, basic algorithm design, analysis is important. Some of the more advanced topics, nobody would ask you in industry about NP is equal to P and go solve this one or solve that. But you will have to reason almost every day about the basic complexity of an algorithm or the best way to apply a certain technique and the like. So the foundational algorithms are really important as well.
So outside of school, while they are in school, there's a chance for them to hone their skills overall. What do you think are things that they should be absorbing outside of school?
I would start the habit now outside the school to keep track of what's happening out there. If you join industry tomorrow, you will, in a sense, have stopped learning what the college stuff is and you started going and learning what's happening out there. And things move very quickly out there, as you know. So start right now understanding what's happening in general. So know the fundamentals, but also know how people are applying them. Be curious. I mean, I sometimes bring up a browser, look at an application, say, how have they done this thing? And oh, it's Ajax, they're doing RESTful APIs, and so forth. So learn to be curious from right now, and learn to link what you do with what you see around you as well. And that habit has to start early. And don't stop it. Keep going. The worst thing can happen is for you to go to, I don't know, industry and spend 5 years doing the same thing and nothing but that. You have to be able to be curious and see around you as well. And that habit has to be started right now.
So the next question is very specific to you and your own journey. From a student in the 80s to becoming a leader in your chosen field, what are some of the skill sets you wish you had acquired when you were still a student? If you reflect back, what are the things that you would have done differently or learned differently as a student that might have helped
Honestly, I mean, I'll be quite honest with you. I took the least amount of humanities I could get, and I loaded my schedule with CS and EE classes and math because it was the fun stuff, the heavy stuff. And don't get me wrong, this stuff is important too, but take a balanced view to things. The humanities are important. Knowing what's really around you beyond just the actual code and the bits is very important. And the reason is very simple, really, which is part of my last answer. When you go out there and do things, you'll be expected to lead, to work with others, and to tell them where to go, if you will. So you can lead them, or you can follow. It's better to lead, to be honest. And to lead, you need to have soft skills and the ability to understand people. So learning about the humanities, learning about critical thinking and writing are actually very important. And sometimes we in academia don't pay enough attention to these things, to be honest. So it would be great to make sure you hone your skills in that space as well. I mean, a critical, for example, in the US, a critical English writing class may sound, too much work, and why do I need this? But it can really hone your skills for critical thinking, critical analysis of the language. So fast forward 20 years, or in my case, more than that, and you have to send an email explaining why something is going right, is going wrong, etc. Conveying the message in 2 paragraphs or to some busy people, that's actually a skill has little to do with writing code, to be honest, but more of, can I put my thoughts down to paper quickly and clearly and concisely? So those softer skills or analytical skills are important too.
So this is more of an advice for me, or professors like me, from your experience. In your opinion, how do you think we can better prepare our students to be ready for the workplace?
There's a couple of dimensions. One is, just to build on the last thought, and then we'll switch to a different point. One dimension is that in academia, you're going through a class. You're going to give a grade to every student, and the grade is his or her grade. So in academia, we basically look at the individual performance. Did I pass or not? Don't get me wrong, the same happens in industry. But to get to do anything in industry, you have to collaborate. So what's usually missing in the more academic environment is how to build software, for example, in a group. And how to do the soft skills for building software in a group. And those things are hard to get, I know, in academia, but it's something I wish we can get more of the graduates with that background, if you will. You typically have something in you when you're a good leader, but then when you go join a company and the like, you have to go nurture and do more of that. Otherwise doesn't really work happen. Beyond that, there are some things which would be great if you make sure that the students can push the envelope in ways that otherwise we in industry cannot do. So make sure they have in them the ability to try things, which otherwise some of us who've tried and say it doesn't work, are not jaded by that. So it's important to instill in the students that, and I think you do a good job of that, but it's important to remember that let them push the envelope. Because once you hit industry and the like, you're going to find constraints. You have to ship quickly, there's a deadline, etc., and you may forget about what's possible. Never forget what's really possible.
So do you have any final thoughts that you want to share?
Again, thank you for the opportunity. This is great. I hope you enjoy his class, because I'm going to actually plan to take it, okay? I'm not going to take it for grade, okay? But I'm going to go, I want to see it. I'm looking forward to it. I think it's a great thing you're doing, and I wish you real luck.
Well, thank you so much, Yousef,
Thank you,
for coming and joining us. And let's thank Yousef for being here and sharing his thoughts with you all.
Thank you.